Welcome back to the 8th part of the Satisfactory tutorial. In this part, we're going to be going over the mining system so we can finally finish the kind of whole system we have. Currently, we just have crafting and storing, but nothing that actually spawns items in the first place. So we're going to be making that. We're also going to make the interface for the containers, because currently they just fill up, but we don't know, or we can't handle any of that. So we're doing that as well. And one extra thing we're going to start off by doing is, in the past we made our conveyor belts and we used a system to check if they are buildable. And so that system is rather bad. So to fix it, we're going to be remaking it here, and it's going to be a lot lighter on performances, because previously it would do a line trace or a box trace even for each different section of the spline mesh inside of, well, the conveyor belt, which can get pretty heavy. Now we're just going to do it with a bit of math, which will do the exact same thing, but a lot easier. So let's start by doing exactly that. So we'll start by opening up our conveyor builds right here. And we're only going to be modifying the actual condition is buildable. Now this part all here is fine. We just check if we're moving on the end here. We check first if it's too short. If it's too short, we don't have it. Then we check if it's too steep. So this is handled right there. And here is where we checked whether if they overlap each other, if they're too sharp of a turn. Now we can do this a lot easier with just a dot product. So that's exactly what we're going to be doing right here. So the first thing we want to do is we want to get rid of everything past this point. So we can remove that, and we'll just move it to the side in case, but we don't really need it anymore. We just want to keep these, the sequence and the set collision. This is just for the sake of it being easier. We don't have to do it this way, but we just keep it. So we can remove the second pin. We're only going to need 2. And the first thing we need is we need to make a new local variable. And that local variable is going to be a vector. So we'll just call it direction. Direction, like that. There we go. And it needs to be a vector. So once that's done, we can then place the vector here, because we need to actually change it first, because there needs to be an initial direction. And we're going to be doing this locally, so the initial direction is 1 on the X, because that is forward. So we just put that to the true. You could also set this in the default variable, that works as well. In the default value, sorry. So what we need to do now is we're going to actually move that out of the way, because that's still too close. Let's move it away. What we want to do is we want to get our direction, and we're going to do a dot product between our direction and the current start point and the current end point, between of what we have here being our current spline mesh. So we're going to get that, our current spline mesh here. We're going to say get start position, and this is local. So this is relative to the actor here. We'll do the same thing right below with get end position, like that. Line these two up just to keep it tidy. And we will say the start minus the end. So you make very sure that you do start minus end and not the opposite, or it won't work. And we then normalize this value, which we then plug into the dot product. Now, if we just run this, we can check with a print how it works. So let's just get that in here just so you can see how it functions. The dot product just checks how close one angle is, well, how two angles are one to another. So that what that means is, if we have, for instance, if we take our first case, we have the vector being 1, meaning it goes forwards. Meaning if the value is -1 going in the opposite direction, then we have a bit of an issue. It won't be allowed to build, which is exactly what we want. But if it's, for instance, slightly offset by, let's say, a 5-degree angle, that's not a problem, because it is aligned close enough that it won't have any problems with the mesh. So then once we have that value here, we'll compare it to a specific value, which in my case I found to be 0.6, but we'll show you just to give you an idea. So if I press 2 here, nothing happens because we're on the start. But if you add the second one, we get -1, -1, because we are going straight, right? But if we start going to the side, we start getting different values. Now I'm just going to check something, because it is negative. So let me just see that it's not positive here. No, so we might have to swap it around. So here, as you can see, it's become 0.9 instead. Now the further we go, the more off the values will get, because the more they're actually rotating. Now currently we have a problem, because it's too far rotated here. So I believe that is the 0.5 here. So what we're going to say is 0.6. If it's in between 1 and 0.6, we're good. We want to absolute this. I forgot to absolute the dot product. And so what this will do is it'll make it positive. And so what we want to check is we will see whether this is inferior to 0.6. And if it is, meaning that we go below that 0.6, that is meaning it's too sharp, then we will simply say return that we can't actually build it. So this will stop the loop and it'll be a lot lighter than before. Now, for this to work, we still need to actually update our direction. So to do that, we're simply going to set our direction here at the end on the second part of the sequence, like this. And what we set it to is very simple. We just copy this and plug it in right here. Now you need to make sure that this is done in this order. Otherwise, you'll end up with an issue where it's updating before testing. And that's not correct. That won't work. Or at least it will. It just won't work long term, let's say. So now normally if we go and try this again, if we do a straight line, there's no problem. If we go slightly offset, the same as well. But if we go too far off, where we start to see this kind of overlapping, it won't be able to be built, or we won't be able to build it. Now, if we come a bit closer here, we still have it. It's probably very slight here, but once again, you have the same issue. But if we move it here, it'll start normally to become visible. I think this is still just too short. Still considers this an issue. Obviously, you can tweak this value, but here it now works. So if you want, you can move it a bit lower, and that way it's more precise. But the lower you go, the more offset you can actually have, the more visual glitches you'll have. So the higher, obviously, it will be the opposite. The higher means nothing can go off. It will always be straight. But we want it to be a bit modifiable, so we use 0.6 here. And so that does it. So that will make the kind of computing a lot better than having all of these run and testing if they hit. So we could also actually remove this. This isn't actually very necessary. So we can just do that because there's no more line traces, so it's not necessary anymore. Just move that to the side. And we can also get rid of our spline mesh data. So we can get rid of all this now. It's no longer necessary. So we can compile and save. And we are done with the building container. It's now a lot smoother and should have less lag if anybody was facing lag in the past. So the next thing we want to do now is we want to add our mineral veins. So for the mineral veins, what we want is, well, actually, we'll just import both of them. We have 2 new items, which will be in the description below in the Google Drive. And so we're going to add those to assets. So I'm going to go and pull those in now. So there's 2 of them. There is the miner and there's the mineral vein. So import them by default, nothing special. And we can put the miner actually in our buildings. There we go, move here. And I think that moved both of them. Yeah, so let's just move that back out. Move here. There we go. So what we want to do is we'll start by making the actual mineral vein itself. So to do that, we want to make a basic actor here. We don't have any pre-built parents that we want to use for this. We just want a basic actor. So blueprint class actor a underscore mineral vein will do for the name. Now, what the mineral vein needs is very simple. We want a static mesh because we want to know what it looks like. And we will plug that in here. And we will select mineral vein that we imported, which will look like this. Now, it's going to be rather simple what we need to do here. Most of it will happen in the actual other areas. So what we want here is very simple. We just want to know which minerals we're trying to mine. Now, to do that, there's 2 methods we can use. Either we can use the DA item, or we can use the DA recipe. Now, it's more interesting to use the recipe, because that way we can immediately tell a miner which recipe to use for crafting, because we're going to be using the A buildings again, so we'll be using the crafting system. We'll just make recipes that don't require any input and just have an output of, let's say, iron ore. So we'll be making those in a second. This is the recipe we want to use, so we'll call it resource, and it needs to be instance editable. So make sure, so that way, if we go and add one right here, we can say that this one can make iron ingots. Now, obviously, these aren't adapted because they actually need an input, and that's not possible. So we won't do any of those for now. We'll just set up everything and then we'll move on. So as far as setting up, we don't need any of these functions. All we need is interaction. All we need to know is what we can do, right? To interact, we already have our BPI, so our blueprint interface. So we're going to get our BPI interact. We're going to call our two functions here. For HUD, we're simply going to say set interact text. And this is for when we look at it, we know what we're dealing with. So for that, we get our resource, we get our output, and we get a copy because we're only going to have one anyway. We split this from our item data. We can then get our name, and we can then format this so that it doesn't just say the name, but says something like to mine, and we just have name here and plug the name in right there. And so now if we go up to it, as long as we have selected a recipe, now this isn't perfect, but we'll set the iron ingot for now. If we go up to it, we will say press E to mine iron ingot. So that's what we'll be doing. So this is rather simple because we already have most of the functions set up for crafting. Sorry, not for crafting, but for mining. So from our player character, we can say pick up item, which in and of itself has nothing for now. But what we can do is we can say here, pick up item. And one of the problems we'll have here is because sadly in our mineral vein, we don't have a reference to an item. So to do that, what we can do instead of making a create an actor just to get rid of it, we'll just add the override here. And that way we can simply plug in the override instead. So we'll do the same trick as here, get the outputs, and we will recombine. And normally, so we want to plug this in directly. Now, if you do it this way, it means that you can also make recipes, because we could split this and say we only import one at a time. But if we plug it this way, we can also just directly tell it if we want a resource vein to, for instance, craft 3 a second, then that's possible as well. Or 3 per recipe, let's say. So that does it for the mineral vein. There's nothing else we need to do here. We can go ahead and close it. We just need to make it so that we have our proper recipes this time. So in crafting, we're going to make some new recipes. So we'll just duplicate the iron ingot for now, and we will say DA underscore, say M for mining, and it will be iron ore, because that's what we're going to mine from here. So open it up, and this time inputs we can just delete. We don't want anything, and we want it to take 1 second to craft 1 iron ore, in essence. So that's the kind of logic we'll have here. We'll craft an iron ore a second. So turn that to iron ore. We can leave the hammer, it doesn't matter, it's not useful here. Now, so what this means now, because of what we did earlier, if we press tab, we have no items, but we can go up and actually mine an item. So currently it only does 1 every click. So we're not actually going to cover setting up mining over time, as that's just a kind of basic input system. So you would just have to modify how the interact works here. So it's not really something that I want to do here, because it's not something that specifically is, or at least is not special to kind of how Satisfactory works. It's just a basic input system. So what we'll be doing now is we no longer need our player character actually. We now want to start getting the actual crafter, the miner. So let's do that. So from our building here, we're going to right click, we're going to create child blueprints, and it's going to be a buildings miner. Let's just put our underscore so it all has the same naming convention, and we open that up. So once again, same trick as before. We're going to start by adding a static mesh like with any other system we have done. The static mesh is going to be our miner right here, and this is what it will look like. So we'll stand up a bit above, and what we'll do is we'll make it fix itself to the actual mineral vein, as that's the only place it can be used. So that's what we'll do. So we also need to add an output. So just to make things easier, so we don't have to set everything up twice, we'll go into our container. We only want the output, so we copy the output and we place it here. Now it appears in the wrong direction, so maybe what we'll do is we will rotate this, because I think that'll be better. I think I made it the wrong way around. So just rotate that 180 degrees. And we can move this thing by 5 would be better. There we go. Now it fits perfectly. And we can make it a bit bigger if we need. I don't think it's specifically necessary. There we go. So we'll just make it like that so it's a bit bigger than it needs to be. So with that, we have our attach point, we have our static mesh. So that's the basic setup we need for any new building or structure that can craft that we have. So we just need to make some updates to conditions and stuff like that, because when we place it, this works differently than any other building. So we want to look for IsBuildable right here. Now for IsBuildable, what we want to do, we don't actually want to keep our parents. Now the parent by default I think is empty. It just says true. We never actually ended up modifying it, but just in case, keep it here, because I don't believe you can actually call it back. If you search for parent, it doesn't actually exist. So what we want to do is we want to get our actor location, and what we'll be doing is we're going to be doing a line trace by channel. And we want to see whether below us we can actually hit a mining vein. So this is actually going to be plus 200 because the actual starting point, in the viewport is below the actual item itself. So we start at plus 200 and we go down to the actual location, which will hit our mineral vein. So we can then break our hit here, and we're looking to cast to a mineral vein. There we go. Now, if we don't hit that, like our cast fails, then we want to return false because we can't place the item here. Now, if we do, we want to get the resource here. I think I misspelled that. Yeah, it's supposed to be 1S. So let's just quickly go and fix that. There we go. Let's close that. So what we want to say with this is we want to say we want to change the crafting recipe because it's no longer the same as before. So we want to inform it that it can start crafting pretty much through this. Then we want to say CE start crafting because we've just connected it. So then if this happens, we put return true and we start crafting because we can. Now there is no outputs yet, as in no conveyor attached, but it doesn't matter. It can still start crafting alone. It's not a problem. Then we want to do our update location because we need to actually move this differently if we hit a target that we need. So in update location, we'll have to do the same thing. So we'll detach the parent here, but we do want to keep it. We're going to get hit information again, and this is going to be at the end. We'll put a return here because we're going to need a few different options. So we're going to break this. We're going to cast to mineral vein. So right here. And there we go. Let's just attach this here. So if this is true, we want to get actor location, not set. And we want to set actor location. No, not local offset. Location set. Actor location like this. And we plug that in, meaning that we put it to its location right there. Now, on the other hand, if we go here, and if we fail this, we want to check whether we're equal to self. And the reason for this is because by default in our update location, in our FPS Satisfactory right here, and so in our line trace, we don't actually have anything to tell it to ignore a specific actor. So what we can do here instead is we will add to our line trace from camera. And so this will be a bit of a problem because by default, it can't really handle this. We can't change it from pass by reference because this time it's an array, so it always needs one. So we just need to add a make array empty for all of these. So just copy this. There we go. Right here. Right here as well. There we go. And normally that'll remove our errors. And what we want to do is in our moving build here, we want to get our item to build and tell it to be ignored by the line trace. That way we don't actually hit the build we're doing. So that way we can ignore this option right here. So if cast failed, okay, let's move. We simply tell it to move like it regularly would. So compile and save. And so with this, we can now move our item, but we have no way to spawn our item. So we're going to have to add a quick input for that. So in our inputs here, we're just going to duplicate object and put it 3. And we don't need to do anything else. Open IMC just so we can add it in here. And we're looking for object 3. We'll select the third keybind. And we can close this. And in player, we just need to add that in our event graph, I believe. Right down here, we want to get object 3. And on started, we'll just do the same thing right here. And we just have to select our miner right there. So normally now, if we press 3, it appears, but we have, for some reason, it is still hitting. Okay, I think I know what it's hitting. So what it's hitting is actually, it's hitting the box. It's hitting the attach point, sorry. So the attach point is the problem here. So what we could do is we could tell it to avoid all attach points. So maybe instead what we'll do is in miner, we'll need this as well. We'll just put a branch and say if this is double equal to our CA output, then we just want to return, meaning we don't want it to move, and otherwise we just move it compared to the parent, and that should fix the issue, I believe. It does not. So let's try and figure out what it is hitting very quickly. Okay, so it is hitting this. I think the problem is we need to say get actor because this isn't considered a valid hit. So if we do that, it should fix the issue. So let's go and press play. And now, yeah, there we go. So now it works. So now there's no problem at all. It just doesn't respond to if we hit our attach point, it doesn't do anything. But once we move away from it, it understands and it starts moving again. So you can leave this that way if you want. It will just not cause any issues. If you overlap it, it will just stop moving. But if you want something more complex, or it's not specifically more complex, it's just a bit longer, and the tutorial will probably be long already. So let's just leave it at this. And this is all we are going to need, I believe. Now we're just going to have a few problems with the actual crafting system itself by default. So we're going to have to make a few modifications here and there just to fix it all up. So if we go and play and place that over here, and if we press 2, we should get items coming out. Now, I don't believe they're what we want. So those are iron ingots, and that is not what we want. We don't want that kind of input. So if we close that, why is it getting... Oh yeah, because we forgot to change it, sorry. Place this to iron ore. And if we press 3 now, we should get the same result, but with iron ore this time. And so it crafts and stops. Now, currently, one of the issues we have is it's going to keep on crafting even if there's no space to keep crafting. So that's something we're going to need to fix very quickly. So that's going to take place in the actual parent buildings, so right here. Most of what we're going to do, most of what the changes are going to be in here anyway. So one of the first things we can do is actually in the can craft. So go ahead and open that up. What we want to check for is we want to check whether we have enough space to build the items, to build the next item. So for that, we want to get our outputs, and we only want the values here because we want to check whether the value is full. So to check that, we do a for each loop, and we already have a function of this called isSlotIncomplete. And we'll just move this because we need a bit of space. There we go. Now, if slot is incomplete, then it's fine. That means there's enough space to actually add the item, and we're okay with continuing. Now, on the other hand, if it's not, that means one of the slots to craft is full, or to output is full, meaning that we need to stop the construction because there's not enough space. So we put output false. Now, if we reach the end, we just plug it back into the inputs, no questions asked. That's compile and save. So to just check if this works, what we can do is in our A buildings, we're just going to get our input and we're going to make it visible, and we'll do the same for the input and the output, sorry. Yeah, just in case to be sure. And we will place an item and see if it actually crafts. I'll fast forward this just to be sure. As you can see, output starts and the number is increasing because it is crafting, and I'll get back to you once it is full. As you can see, it reaches 100 and it stops crafting. Now we can check whether this is working properly as well by just adding an output, and that will start outputting the items, but the number still stays at 100 apparently. So that is wrong. It shouldn't be staying at 100. So actually, before checking what error that is, I want to actually do something else first. is currently we have a bit of a situation where right here we have mine ore, right? So the recipe we have there will appear here. And that's kind of an issue because, well, there's nothing to craft here and this shouldn't be actually craftable. So at the same time as this, the steel ingot shouldn't actually be craftable inside of here because it can never have two inputs. So that's something we need to set up very quickly that we can do right now. So what this involves doing is we're going to make an enumerator. So this is going to be inside of our crafting gear because we're going to be setting up in here. So in our blueprints folder here, or our blueprints, sorry, tab, we want to make an enumeration and we're going to call it recipe type. And so inside of here, you can make as many as you want for whatever kind of building you want, because that's what we're going to use it for. So the first one will be none of the above. And so that means it just can be crafted anywhere. Then we're going to have mining. And those ones are specifically for, well, the mining ingredients. They're things like the iron ore, they're things like coal, etc. that can't be built by the player or by a machine. They just need to be taken out of the mineral vein. Then we have smelting. We can then add another one for a foundry, which is for the steel. Foundry, like that. Then we have constructor. We can also add an assembler. And even, for instance, the manufacturer here. So we're not going to be making any of these, but these are the ones that you could have. So we can then close this, and we need to obviously inform our building of this, because the building by itself doesn't know. So to add this, we simply want to make a variable, which will be building type, and it's going to be of type or recipe type. There we go. Now by default, we'll leave it as none of the above, but for our children right here, where we have, in our case, this being a smelter, we will tell it to be, well, exactly that. So inside of our class defaults, we're going to, we're going to look for our building type, and we're going to set it to smelting, because that's what it's for. Now, by default, this does nothing, because our smelting, well, doesn't have any information. So to do that, in our crafting, we need to tell which recipe is of what type. So we'll add under our hammer the recipe type. And it's going to be obviously the enumerator we just made. So call that as well. And we can open up the different ones in here. So for our iron ore itself, it is mining. For our iron ingots, it is smelting, because we're melting the iron ore. For the steel beam, it is actually a constructor. And for the steel ingot, we're looking at a foundry. So now with this, it still won't change anything, because we haven't told visually how to handle it. So what we need to do is we need our actual interface to handle this, because by itself, it doesn't actually do anything. So to do that, in our building, we need to go and modify our UMG building. So let's open that up for crafting. Go to the graph, and so all we need to do is we just need to change which ones appear. So to do that, we go into our event graph, and we just need to modify this right here. We need to tell it if this is the recipe, well, you don't actually get to craft. Or you at least, no, you can craft it, but you don't get to actually see it to craft it. So it's the same thing. So from our DA recipe, we're going to get type, and we're going to check whether it is double equal, not that one doesn't work, double equal to, from, if I remember well, our component, which is building, we get the recipe, not that one. I think, sorry, no, it's building type, isn't it? Get building type. And if these two are double equal, then we can simply put a branch. If they're double equal, they can come in. If not, they don't get added. So the result of this is that if we go and select here, our smelter, we only have the iron ingot, because that's all we can craft, because none of the others fulfill the condition. So that will do it for this. Now, what we can do is we can just line this up here, so we can test whether the constructor is working and the minerals are being extracted correctly from the vine. conveying, sorry. So if we plug this in here and we get a conveyor belt, plug it in here, it will stop normally because we haven't selected our recipe yet. There we go. But if we select our recipe, one comes in, it starts crafting, no problem. And we can also check here whether the number is, okay, so the number is continuously increasing and not actually going down. So we have an issue. So it is stopping when it should, but the number isn't going down, so that is a problem. Inside of our start outputting here, we actually never updated this to our new one, which was output map modified. And so if we plug this in correctly, that should solve the issue. So let's see if we plug that in and we go here inside of our, well, first, obviously what happened here is needed. So that is necessary. The problem actually lies here because it's not actually calling this. And I'm not sure if well, obviously because it's not for me, it's not there in your part as well. But if this happens on not valid, we should also be returning true, because this is just a matter of showing visually that it has changed in the UMG. So if it doesn't happen, if we don't have the UMG, we still want to craft, we still can output, so we output. So that way we then get to our modify output map and everything works just fine. If we run it, add our crafter here, not our crafter but our miner. And if we check, it goes up, down, because it's crafting and outputting at the same time. But if it blocks, it'll start increasing because it's no longer outputting. And let's just check if it does again block at 100, just to be sure. I'll join you then. So inside of outputs from our actual modify outputs, we're actually using input for some reason. So this is completely wrong. It should be outputs, obviously, for all of these. There's no reason for us to look at inputs, especially adding to inputs. There's absolutely no reason for that. So I think if we move this to the side and we add a branch, which simply checks for our crafting recipe, and we get the inputs and we check that they are not empty, because this crafting system that we have doesn't need any inputs. So we return that it can craft because it doesn't need the inputs. And otherwise it's going to do all these checks and it's never going to find what it needs and it's going to cause it to bug. So this should, if not fix our issue, it will fix other issues that we would have had down the line. So I finally, after an hour of trying, found the problem. And let this be a lesson to anybody watching. Sometimes it's the most stupid things. Sometimes it really is. And in this case, this single thing that I have in my one, in my code on the right, that I initially only put for the update crafting progress, is actually what causes that to actually work properly. So what it does is very simple. It just resets the timeline back to the beginning once you finished outputting. And the whole reason is because here we, how to put it, when we finish crafting, once we've reached the max, I believe it is in start outputting here, I think in modify output map, we use resume and not start. So what's happening is once we reach the end, we just keep on going from here, and it never actually works correctly because of that. So we need to make sure that we set it back to 0. And that's what this does, and that actually solves the issue that we've been facing. We can move on to the next step, and that next step is our containers. Because currently our containers don't really do anything, or at least they don't do what we want properly. Because what we want them to do is we really want them to, how to put it, we want them to be interactable, right? Because currently, if I am correct, we can open them, but that's not what we want, right? We don't want to see recipes or production. We don't want to make anything with these. We want them to have their own widget. So that's what we're going to do. But to do that, we also want to make a few modifications because we're going to take advantage of the fact that we already have an active component that deals with an inventory system. So we're just going to use that. So let's start off. We'll start off by doing the UMG. and then we'll deal with actually taking the information over. So obviously we start with getting our container, because without our container, we can't do most of this logic. So we're gonna have to override our interact here by getting interact with actor. And we're gonna use this to do the same thing that we did in our actual base class, but this time we're gonna do it specifically for the container. So we'll get our widgets and we will create a new one. So user interface, widget, UMG container, we'll call it. Very simple, that's what it is. Place it there and we can get started. UMG container, very simple. Start with a canvas panel. And to make things easier, we will add a second canvas panel, which we'll just put in the center. 0.5 on the alignment, center it, and something like 0 for the obviously location, 1.3 and 720. Now we can then add a button in the top right that will make red so that we know it's for closing, and it should be in that canvas panel. There we go. So top right, 1 on the alignment on the X, that way it automatically fits right here. And next we can add our actual inventory. So we'll say our all items, because that's what we need. Now in this case, the relevant items won't really be necessary because, well, all items are relevant, it's an inventory. So we can place this in the right as well, and we'll put it on 1 on the X, 0 on there, and I think 60 on the Y, just so it's a bit down. Make it 300 on the X size-wise, and 660 as usual, like this. Now, next we want to add a basic inventory grid here, like this. And this inventory grid is going to be 700 by 420. It's going to be 70 by 70 scale, and obviously this is up to whatever you want. Just make sure you use the same, or actually it doesn't really matter what you use, it's fine. It's just so that make sure it lines up correctly with how many grids you want to have. So this will be something like 280, I think will be fine here. Doesn't really matter too much. We'll just add an image behind so that it doesn't, so that we can actually see what we're doing. We want it to be there. So I want this to be something kind of dark gray, and we'll set it to fill. There we go. Maybe a bit darker than that, to be honest. There we go. So let's start by setting this up. I think that's the first thing we can do, and then we'll get everything ready, because most of this is very similar to what we've done with the inventory before and other things similar to it. So as far as information goes, we need 2 inputs or 2 variables, and these are going to be the player, not like that, player inventory, which is going to be AC inventory. And we can make sure, first we make it exposed on small and instance editable, then we can duplicate it and we'll just call it storage. So this is the actual inventory of the container. So we start with a sequence so that we can do both of our things here. And what we want to do is we will get our player inventory. We will say AC inventory, set, I believe, from UMG all items, my bad. Set AC inventory to the player. Attach it like this, line these up. And we also want to do construct late, because we want to make sure that this gets called only once we've set our AC inventory. There we go. Now, next what we need is we need to do the same thing for the storage, but this time it's a bit different. We want to get our max size here, and we want to set our grid here to grid size, it's called. Grid size, not get, set grid size. And the reason we have to do it here is because here we're not using our pre-made thing, we actually need to use something separate. And so here we will say with our grid, create background, starting index 0. And finally, we will say create all grid items, and the grid map is our storage and our inventory. So get that and plug it in right here. There we go. So line those up. And one last thing we need to do is we want an event dispatcher called close, and this is just for when we close the widget. And on our button press, we will do exactly that. We will say close, call it right here. We'll bind it inside of our container once we've finished all this. Now, one thing we can do, and it's something that somebody pointed out in the last videos, is you can kind of duplicate items if you drag them, close the widget, and then release them once you open the widget again. So to avoid that duplication, we want to get on destruct event, and we want to call an operation called cancel, drag, and drop. So simply what it will do is, if we're dragging and dropping, then we'll release anything, or cancel it more like to be precise, once we close the widget. So that way we don't have any problems with that duplication glitch. So now we want to get our inventory grid here, and we want to say if we modify it, that we need to modify our actual storage. So we're going to say item removed here, which will get plugged in right here in the key. And we'll do the same thing for item added. There we go. And so both of these will kind of update it just like we did in our normal inventory, the same thing, or more like in our all items. It's identical to that. So with this, we just need a few different functions here. We're going to need one called item input, and it takes in a structure, so st inventory, and so we'll just call it structure. And very simply what it does is it will get our inventory grid and say find spot for item, simply plug in the structure. So this will be called for when an item comes in into the container, not the player putting it there. Then we have the same thing with item removed, so it's going to be item, maybe output is better. And it's going to be this time a key because we don't need anything else. So once again, with our grid, we will say removed item, and we'll take the key in. So just rename this to key actually. There we go. Sorry, no, I actually got that wrong. We actually have two things. This is item removed, and then we also have another one which you call item output. So I actually got those mixed up here. So item output actually needs also the value. So that's going to be value, and it's going to be st inventory. And the reason for that is because we need to know how many items, because we remove item one by one, we can't just say get rid of it as a whole. So we're going to get our grid inventory here, and we're going to update the specific one of the key. So we'll find our key here, not that key, our get key variable here, line these two up. And what we want to do is we want to call update quantity. So plug this in, and the new quantity is going to be our st inventory break, and we want to plug the quantity in here, as because we're outputting it will just return we'll be telling it to be the item that's remaining, so just -1. So now we can close this. We no longer need this UMG container anymore. We'll just be making it appear now. We'll start by doing that. What we need first is a reference to it. So we're going to start by saying create widget, and that widget is obviously going to be our UMG container. Plug this in, well, not yet. First, sorry, we'll make a variable, which will be UMG container widget, we'll call it, or just UMG container will do. And we're going to obviously check if it is valid right here. If it's not, we create. And so what we need to do here, currently we don't have it, we're going to add AC inventory. Now by default, what we're going to do is we're just going to modify the variables here because we want it to be a bit bigger. So we'll say max size 60, allow duplicates, and nothing else. This will be fine. So currently it won't work because we need to make a few modifications for it to work perfectly. But first we'll set up making it appear for now. So here we want to get AC inventory of the player and plug that into here so that we know what the player inventory is. And for the storage, we'll just get our AC inventory and just plug that in as well. So just move this to the side. There we go. Next, we're going to bind close, and we'll just create an custom event here, which we will call remove widgets. There we go. And we'll simply say UMG container remove from parent and just set it to clear for now. let's just also, while we're at it, we will just quickly open our, I think it is our buildings, and we will just copy this, because either way this is always going to be used. So we'll just copy that and place it here. And because it's using the same logic as it's a child, most of the stuff will be in, all of it will be the same, sorry. So with this, we then want to add to viewport, plug this in, and we can connect everything up now, and that should be everything done for at least setting up our widget here. So let's just check, there we go. And that should be about right. So now normally if we go and interact with this, we get our container. So there we go. So it's working as intended, 0 to 59, no problem. Now we're gonna get some errors. So let's see what those are. Yeah, sorry. So the reason for that is that we don't actually have a reference to our player here. So what we do instead is we just get our player ref directly. It's not the cleanest way to do it, but it'll work for what we want. So it'll stop the player from moving. There we go. Line this up, and I'll do the trick. So we won't have that error anymore if we interact. Okay, good, no more error. So let's go to the next part, which is actually fixing up our AC inventory, because currently it is not going to work as we want. Actually, one thing we do need to change is currently we use storage here, but we're not going to be using storage, we're going to be using AC inventory. So what we can do is we can make a macro for that. So this is going to be our inventory. And make sure you use a macro and not a function or it won't work. We want to get inventory, and we're just going to pass this out. There we go. So compile and save, we don't need that. What we're going to do is every reference to our storage, we're going to find the references and we're going to replace them with our inventory. It is exactly the same type, so there should be no issues replacing it whatsoever. So let's just copy this around. Go. There we go as well. Remove all of them. And once they're all gone, we can just simply finish the last little updates and it should be functional. At least it'll be working more or less. The inventory will still need some minor changes. So there's quite a few to go through. Just a few more and we will be done. I think this is the last function that has them. There we go. And just to be sure if everything is working, we can now select the eyeglass just to see. And normally none of these actually exist anymore. So if we go and compile and save and we search for them again, we have nothing and we have nothing outside, I don't believe. So we can just close this and it'll be fine now. So what we need to do next is we need to make sure, because currently this won't actually work properly. So we need to make sure that it does. What we need to do here, so yeah, so we don't need that first off. It's just a bit of an extra line. What we can do here is with our UMG container, we can tell it to update itself. So here we're going to say item removed because an item is completely removed. So we'll just go here, copy this, and plug the key in. This means that the item is no longer visible. Then we need to do the same thing. Well, actually, no, sorry, I made a mistake here. We need to make sure that it's valid because sometimes we won't actually be looking at it and we don't need it to update if it's not there. So we'll copy this again. And this time, so in this scenario, it means that the item has been modified, not that it has been destroyed, but modified. So we'll call output item. And so here we'll get the key as well. And normally, because of how this works, so normally what we can do here instead, we should just be able to copy this directly because it has been modified. So just place it here. Make sure you remove this because this value is being set to this value here at the end. So this would be invalid if you do the minus again. So one of the advantages of this system is for can input, we can modify this a bit. We no longer need that. What we simply need is we can get our AC inventory and search for isplace, or sorry, item has place for item, split our structure and plug this in. And if it has place for an extra 1 because it's just inputting items 1 by 1 anyway, then we know that the item can fit, so we can input it. Yeah, so one thing we don't actually need, because we're going to be using the inventory directly, we don't need to actually use modify input map here, so we can delete it. What we do need is we need input from attach point. So input from attach point is what we're going to be overriding here. So we'll move this to the side. And what we want to check is pretty much very similar to what we had before. We want to get our structure. So some of this is going to be almost identical, sorry, not watch. We want to split. And we're going to check can input item. And so if this is true, then we can input the item. If not, then we want to actually return. But in addition, like in the old one, we want to get the attempted input and add the current item we are trying to input. So just get here, we're going to get attach point, and we're going to get the input item. So line these two up. And what we want to do on true is, once again, we're going to use our inventory that we already made and say pick up item. And the item we're going to be using is our input item. And this will do the trick of everything else that we wanted to do. Now on false, obviously, that means we can't, or we failed to input. So we return that we failed to input. Now, if the widget now is visible, we need to update the information within it. So to do that, we want to call our input item function that we made. So input item. And because we don't have this structure, but this time we actually have an item, we can get that structure again. So we can just plug the structure directly in here like this. And make sure that even on invalid, we actually want to make sure that we continue the code, otherwise it won't work. So a sequence here will do, and we're going to get our input item, not that one, just our input item. And we're going to get our conveyor, and we're going to call a function which is picked up. Now, attach it like this, and on return, we're going to say true that we managed to pick or remove the item. So there we go. So the last thing we want to do is we want to get our CA output here. So specifically this one, we want to get child, and we're going to cast this to our attach point because we need to get some information, and that information is we need to know if there's a conveyor. And if there's a conveyor, we want to know that we can actually start outputting. So from here, we're going to get our, I believe it is called connected build. So get connected build. And the reason we do this, by the way, as a pure cast is because we're sure that it's going to succeed, because the child actor should always be an attach point. Otherwise, it shouldn't work. So we want to convert to validated get for this because we're not sure there's an attached actor. But if there is, we want to check whether it is a conveyor belt or conveyor build, sorry. We're going to see can spawn next item. And if we can, well, we want to start outputting. So we'll call here start outputting. And then we just go back down to our second part of the sequence and we can return. So with this, we can compile and save. And that should do, and that will do it, sorry, for anything concerning the container. Let's give it a try. So currently, if we interact, it's empty. Let's give it some items. Actually, sorry, I completely forgot. I kind of messed around with our thing there. So let me just fix that for a second. There we go, viewport. This right here just needs to be moved. So I just moved it because I was doing some tests. There we go. Put it like this and back there. So let me try this again. Let's go here, add that, plug this in here. So it should be crafting in more than enough. And if we plug this in, once it starts building, so it has a few already in there, it adds 1, it adds 2. We have 2, then it should say 3, 4, 5, and so on. So it will start increasing. Now, one thing worth noting is currently if we drag that, we're going to get a bit of an issue. And the reason for that is simply because it still is referring the modifications to the old place it was left at. So if you release here, it's going to go back to 12. It knows that that's the same value. So it's not duplicating anything. It's just a bit of a visual glitch. So normally you would want to say that this disappears, or at least the origin disappears, but we want to keep it. So I'm going to do the next best thing instead of having it modify or add new values there, because we want to still keep the old one. We're going to make it so that it disappears, so it's no longer visible, but it updates what we're holding instead. So let's go and do that very quickly. So that's going to involve going through kind of our UMGs over here. So we're going to go into our inventory file, and we're going to have to make some modifications here. So let's go ahead and open. I think most of these need to be open. So if I don't believe inventory though. Well, we'll just keep it open in case. So I'll just go through them to make sure. So let's just start with item first. I think that's the easiest one to do. So what we want is we're going to start by making an actual reference to the drag visual this time. So the drag visual has a so that when we drop or modify it, it knows what the item is that's moving. So we'll call this, well, it's going to be UMG item, because that's what it is. Let's go and compile. And what we want to do is we're going to, I believe, on drag detected, we're going to start by promoting this. So let's just remove all these extra ones that we don't need. On drag detected, inside of here, we're going to set drag visual. So not like that. We want to grab it here and set it to that. So nothing else needs to be changed. We just want to do that. Compile and save. And so the next thing we want to do is we want to inform it, because what we're calling when we have a new item come in is update quantity. So what we're going to check is if drag visual exists. That means that we're actually dragging something, that we're trying to update. So if we're trying to update, we need to actually inform it, well, to do something differently. So if it's false, we want to keep the whole thing we have here. No problem whatsoever. That means it's a normal scenario with nothing that has to do with dragging and dropping. If not, we want to modify our structure here again, obviously, because the structure is still changing. We just don't want to update it visually. So in that case, we're going to do, we can actually copy the whole thing here. And the only thing we don't want to do is we don't want to set it visible. We want to make sure it stays hidden. But one thing we also need to do, and this is right here, we actually need to, get item structure here and do this. We actually want to modify the structure here, not this one. This one we're going to also do as well. But first we want to update the one that we're moving. So we'll get drag visual here again, and we will get text block 70. And so you can leave obviously this, because that's going to be the input here, so it doesn't matter. But then we want to copy this because we want to do the same thing here, but we just don't want to update it. We don't want to be able to see it, And make sure we also call quantity modified, otherwise it doesn't know that it's been updated across kind of the other widgets. Now obviously on drop, we also need to do the opposite. We need to inform it that it's been, well, dropped, so it doesn't matter anymore. So the first one we want to do is we want to get our old item here and say set drag visual to empty, because that means that we've dropped it and it's no longer here. It no longer needs to be taken into account. And we need to do the same thing all the way down here, I believe. Sorry, not all the way here, all the way here. So here we're going to get our old item, and we're going to set drag visual also to empty. There we go. Compile. Okay, so that should do the trick now. Let's give it a try. So once again, we need to just connect these up, give you a recipe, plug our miner in, and it will start to fill up normally. And now if we go and let's say drag this, it'll start increasing on the actual value we're moving. So it's still actually modifying the one in 0 here, but it's just not showing it visually. Now if we release it, it's 8 here, 9 here, and so on. And we can also obviously move it to here, and then it will start reappearing there, no problem. And obviously we can do the same, move it back, no problem as well. I believe this is because it's finding the last one. So you can modify that if you want, but it has nothing to do with kind of the system we're working on now. Let's close this. Check no errors. It's still increasing normally. It is. And so if we close it, no errors. So everything is working as intended. So as I said, that does it. That does it for the tutorial for today. I hope you enjoyed, and I will see you in the next part. The next part will be the last one, most likely. It's going to be about setting up the electricity, let's say the power generation, and the fact that the buildings can only run if they have enough energy. So that's what we'll be doing, and that will obviously include also the power poles and the cables. So I'll see you then. Goodbye.